Alright guys, so 8.4 is vectors. You might have seen these before, but hopefully this time it'll make a little bit more sense. We'll see. Vectors is kind of like, so I'll kind of show you. This is a vector. So what we think of as array, right, R-A-Y, it's actually called a vector. It has a magnitude as in like size, okay? Like think like magnitude of an earthquake. And it has a direction. So it has this size, it has this length, and then it has a direction that it's going in, okay? So that's what defines array or a vector. There's an initial point, there's a terminal point. So this is where it starts, this is where it ends. And then at the end is, you know, the arrow, okay? This is how you write vector. So you can write it like that. So PQ, it starts at P, it ends at Q. And then a zero vector is a vector with a magnitude of 0. So that should make sense. It's like a size of 0. Two vectors are equal if and only if they have the same magnitude and direction. So they're equal if they're exactly the same size, exactly the same direction. Okay? Okay, so this right here, this means scalar. So this alpha right here, so we did like alpha, beta, all that. Lettering. So this is a scalar, this is a constant. So that's like a 2 or a 5 or whatever. So if you have 3 times a vector, it means that the magnitude is 3 times the magnitude of the vector, but it's going in the same direction. So 3v, if v is a vector, like that's a vector, right? It means just 3 times as long. So this times 3. But then a negative 3v means it's 3 times the magnitude and it's going in the opposite, going in the opposite direction, okay? How to add and subtract vectors graphically. Okay, so this is kind of cool. So basically, wherever one ends, the other one starts, and you want to do it in order, okay? So let's say you have this vector v, it looks like that. You have this vector w, it looks like that. There should be a point there, but it got cut off, all right? And then let's say we wanted to add the two vectors. So you would start with v, and then at the end of v, you would draw w. So I'll show you what I'm talking about right here. So this is how you would draw the vectors. And you would show, so this is like invisible, right? So you draw V, and at the end of V, you draw W going to the right that distance. And then the resulting vector starts with the beginning of V and ends at the end of W, basically. So this vector is the resulting vector, and that's V plus W. So we're going to label everything because we're cool like that, all right? So let's say you did W plus V. So basically, you're starting with a W, go to the right, and then you do V, and then you connect them. So it looks something like that. So this is going to look like the resulting vector is the same, but then you can tell that the setup is different, right? So resulting vector is the same. Okay, so when you add, that's how it works. Okay, what if you have these two that you want to add together? So you would draw V, and then you would draw negative V from the end of V, and then you would show that that's true, right? So something like this. So you draw V going that way, and then at the end you go the other way. See that one? And then I said negative V. So that's just like a point, which has no magnitude. Okay, how about this one? I feel like you should just try it. Come on, try it. Use a pencil. Try it. So V minus W. Okay, so it looks something like, let's ignore this, V and then plus a negative W. That's really what you're doing. So here's my V going in that direction, and then a minus W would go in the other direction. So I go from here to here. This is my resulting vector. So I labeled that V minus W. Okay, so hopefully that's what you had as well. Okay, so this one looks kind of crazy, but you should give it a try. Is it this one? I don't know, we'll see. So 2v plus 3w plus u. So you have 3 new vectors right here, okay? So here's your v, here's your w, here's u, okay? So start, let me see where you should start. Start like down here, and then you'll have enough room, okay? Start down here, give it a try. and then you're going to check. Oh, it's crazy, right? So I went 2V, so there's 2 V's, and then I ended here, and then it says 3W. So 1W, 2W, 3 W's, and then plus U. So here I draw U going that direction, and then from start to end, I connect. That's my resulting vector. Everything else is how I get there, but that's my resulting vector, and then I just label it. Okay, give this one a try. You kind of see the end of it though. 2V minus W plus 2U. I would say you wanna start maybe down here, okay? And then maybe something like this. So I start with my V, so there's 2 V's, and negative W goes the other direction, and then to U. So that's U. It goes a little bit like more vertical, right, than this one. It's a little bit longer also. So from beginning to end, we draw our resulting vector, and then we label it. Okay, so that's generally like how we can add and subtract graphically, and then we'll do it like with numbers too, okay? But first we're gonna do a little bit more like mathematical stuff. All right, so the magnitude we're gonna write like this. So it's kind of like, it almost looks like a double absolute value. It's similar, right? Absolute value is like the distance to 0. Magnitude just means like the actual size of it. And then it also represents speed. So just so you know, a magnitude of a vector can also represent speed. Later when we're doing word problems, that they're going to represent speed. All right, so properties of vectors. So I'll just do all of them here. So the magnitude is always going to be greater or equal to 0 because the size has to be 0 or positive. And then it says the magnitude is 0 if and only if you have a 0 vector. Well, that makes sense. And then if you take the magnitude of the opposite vector, you have the same, right? They're the same size, right? Even if it goes in the other direction. And then this is saying that we can basically multiply in any like scalar. So 3 times a vector is the same as 3 times the magnitude of the vector, or 3 times a vector and then you take the magnitude. And then right here it says the magnitude equals 1. When the magnitude equals 1, we call that a unit vector. So this is going to become common, this unit vector. So like a unit circle, we have a unit vector. It's just 1 unit long, okay? The position of a vector is when the initial point is at the origin. Then we can like calculate the position of a vector. But the initial, like the beginning of it, like P right here, that would have to be at the origin, okay? The position vector, we can go ahead and write this way. Like let's say there's a point and there's another point. So this is the beginning point and this is the end point, like the initial point and the terminal point. What we can do is we can just go ahead and subtract the end and then minus the beginning, and then the end minus the beginning, and then it gives us this position vector. And the vector, when we write it this way, for instance, like you would do this little what do we call that? I don't know. This little corner. So the corner, if we write like 5, 2, then from 0, 0, we would go 5, 2, and we draw a vector. Okay, so like 5, 2, and we draw a vector. So that's what the position vector is for. So we can actually put it on like a coordinate plane. Okay, find the position vector of V given point 1 and point 2. So we have our initial point, our terminal point. Go ahead and plug it in and see what you get. And then we'll just kind of check. Let's see. So you just like subtract and then final answer. That's it. Right? Okay. Okay, so here's where it gets a little bit like different than we've been talking about, but it should make sense, okay? So I have these 2 different colors of highlighter. I would like you to use 2 different colors of highlighter for this, okay? So I highlighted I, and I called it the horizontal component. And I highlighted J, and I called it the vertical component. So this hopefully makes sense that the first like number is going to be horizontal and the second number is going to be vertical. Because if you draw this 6, 5, it would literally be, I'm going to grab my pen. It would literally be, if we were to draw 6, 5, we would start at 0, 0, oops, and then we go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and it's basically telling you to draw that vector. So that's the vector that represents 6, 5. Well, we know that this length is 6, that's horizontal, and this length is 5. So that's why this is the horizontal component and this is the vertical component. I is not a variable. I is just like telling you that this number like is horizontal and this number is vertical. Okay, I'll show you how that works. All right, but it's not a variable specifically. It's not like I represents 2 or anything. That's not true. Okay. How do you get a magnitude? It's the distance. It's the distance formula. All right. Square root. This is the same as like r, right? So square root of a squared plus b squared, because a and b are like the x value and the y value. Okay. So given this vector and this vector, we're going to find a couple things. So the first thing is, okay, how would we add them together? So to add them together, literally, you want to add the horizontal components and you want to add the vertical components, okay? So this is why we have an I and a J, because if they just wrote 5 plus 6, like that would make no sense, right? So now we know this is separate than this. So you just add the I's and add the J's. So then you would get something like this, and then as a vector, we would say 8, 4, and we do those little corners. I feel like I'm saying that wrong. I don't remember what they're called. I'm sorry. Okay, so then can you guys do this one? Try B. Use a pencil. Try B. Do it, do it. And then also for C, go ahead and find the magnitude of V. Okay, so give that a try, and then we're going to check our answers. So here is V minus 2W. I doubled W and then final answer. And then here is your magnitude. So just a squared plus b squared, right? X squared plus y squared. Same kind of thing. Okay. So then a unit vector, almost done with this page, a unit vector is where the magnitude equals 1. And then it says here, the unit vector in direction of V. All right, so basically any vector we can make into a unit vector. So I'm going to give you an example. This one I can make into a unit vector. How do I make that a unit vector? I want it to be, I'm going to get another color. I want it to be 1 unit long. So it might look something like that. So I want that to be 1 unit long, that purple, and then that would be the unit vector representing 6, 5, or yeah, representing this vector 6, 5. Okay, but I want that little unit vector. How would I do that? I would do the vector divided by its magnitude. So let's give that a try. And then we're going to find the unit vector in the same direction as this. So I'm using that formula. So it's the vector divided by its magnitude. I need the magnitude. So then I find, where is it? Sorry. I find the magnitude on the bottom. So I just write it this way, U equals. And then here's the magnitude on the bottom. I keep going. That's going to give me 25, which is 5, right? Square root of 25. And then I can leave it like this. That is totally fine. But usually you're going to see it this way because this makes more sense, is to actually split it up into a horizontal component and a vertical component. And then if I was going to write this as its own vector, I would write this is the same as 4 over 5, comma, negative 3 over 5. So these represent the same vector, right? This is written in a different way. This is obviously a vector. I know which one is horizontal and which one's vertical. And then this one's written so that it doesn't quite look like a vector, but now I know which one's horizontal and which one's vertical, okay? So that's the first part of vectors. All right, we're going to do the back. Okay, day two. This is a little bit more like, ooh, okay. So day 2, it says, since the unit vector has this formula, what we could do, right? So let's think about this. What we could do is we could multiply both sides by the magnitude. If you multiply both sides by the magnitude, you get v equals, and then the unit vector times the magnitude. If I rewrite this so that I'm multiplying the other way around, I would get this, right? Okay, so using this is the magnitude, and then this is a u would be the unit vector. The unit vector, and then the unit vector we could write as like, you know, something I plus something j. So this is another way of writing it, cosine of alpha I plus sine of alpha j. This is basically, remind you, like that, right? Something I minus something j or plus something j, that's the same thing. But the number is represented with that cosine alpha and that sine alpha. Why is it cosine and then sine? Because cosine is horizontal and sine is vertical, right? Isn't this the x value on a unit circle? And this is the y value on the unit circle. So this gives you the direction, and then this gives you the size. What do vectors have? It has a direction and it has a size. Okay, so, oh, right here, direction and size. So you're going to jot that down. Here's a picture that represents everything. That's the unit vector. And then here's your cosine and sine, right? Okay, the velocity vector. So the velocity vector has a direction and speed. Speed is basically the magnitude. Okay, so that's why on the front we wrote like magnitude could also be speed. A force vector has a direction and an amount of force. So that amount of force is like a size, okay? So these are all just vectors, all right? So we can use them in real life using speed, velocity, force, okay? So let's say, or amount of force, sorry, acting on an object. There we go, okay? So it has to be like, you have to push it, right? So force vector. Okay, so let's say for this example, a ball is thrown with an initial speed of 30 miles an hour in a direction that makes an angle of 40 degrees. This is important because this is the speed. What is speed? It is magnitude. And then it has a direction. All right, there's our alpha, right? With the positive x-axis. So this does matter because we should always be going, the angle should always be going around the positive x-axis. So it's a standard angle, okay? Express the velocity vector in terms of I and j. All right, so we're just going to write the vector and then find the initial speed in the horizontal direction and vertical direction. Basically, once you have an answer here, the rest is there. It's like staring you in the face. Okay, so we already know how to set it up because it looks like this, and then we already have all the information we need. So I'm going to remind you, this is actually speed. They said it's 30 miles an hour. The theta or alpha, whatever you want to call it, is 40 degrees. They already told you that. So then I just write it in. So the vector is 30 times cosine of 40 degrees I plus sine of 40 degrees j. And then you like multiply it out. So if you had a calculator, you would get something like this. And then you would multiply times 30, well, you would get this and then multiply by 30. And then that means that your horizontal speed is this much and your vertical speed is that much. So this is the horizontal and vertical component. That's it. Okay? So just knowing how to like define a vector. Okay. So a resultant force, like I said, a resultant vector on the other side is a combination of forces. So it's like vectors adding to each other, subtracting to each other. You get a resulting vector. That's a resulting force. Okay, same kind of thing. Okay, so they said, all right, if we have a force 1 and a force 2 and we add them together, this one would be force 1 plus force 2, right? So they just did it the other way around. So usually I put these dots here, and then this is solid, but that's the resulting force right there. Okay. An object is in static equilibrium. So what's equilibrium mean? Like, think about it in terms of science. Everything's equal. Everything's just like chill, right? If the object is at rest, so that should make sense. If the object is not moving, we're at static equilibrium. And the sum of all forces is 0. That means the resultant force is 0. So that means we're like chill, right? We're not getting pushed anywhere. So both of these would be true. Okay, so let's try the craziest one, all right? So example, we're going to do this a few times every day for the next couple of days. A box of supplies that weighs 120 pounds is suspended by 2 cables attached to the ceiling. So imagine there's a ceiling and there's 2 cables and it suspends like a box. I know it's weird. What's the tension in the 2 cables? So I told my husband about this problem. He was a mechanical engineering major. And I was like, why would you need to do this? And he's like, oh, it has to do with like bridges and this and that. And I was like, oh, okay. All right. So we're going to draw the situation. We're going to draw it nicely. So here's your ceiling. And then you have your angles that are given in the problem. I didn't write them in the problem, but these have to be given, okay? So let's say this has a 30-degree angle and this has a 45-degree angle with the ceiling. So here's our cable 1, here's our cable 2, and then this is 120 pounds, or 1,200 pounds, and it's suspended by these 2 cables, okay? So we want to know what's the tension in the 2 cables. Okay, we can do it. So here's why I drew this, and you want to highlight that as well. This is going to give us the actual angle of each vector. So this is a vector, this is a vector, okay? And we want the angle is not 45, the angle has to come from a positive x-axis. So this is an angle, and this is an angle for cable 1. Okay, so I'm going to redraw it. You're going to redraw it. And it looks something like this. So here's our ceiling. And I know there's a lot going on here. I would probably draw a little bit less on the homework, okay? But I want you to see what's happening, okay? Here's cable 1. Here's cable 2. This is the weight of the object, okay, which is 1,200 pounds. So this is going down. This is a vector. This is a vector. Okay. This has a horizontal component, vertical, horizontal component, vertical. For cable 1, I called them II. For cable 2, I put like sub 2, sub 2. So this is always going to be true. So hopefully, like, I'll explain it and hopefully this will make sense. So basically, this thing right here, if you think about it weighing down, it's not gonna like, it's weighing down specifically. It's not weighing side to side, right? Like gravity makes it weigh down this way. This way is vertical, okay? So vertically, my resulting vertical, what is that gonna be? Like magnitude is 1,200 pounds, okay? So that's like how heavy it is. And then horizontally, it's not getting pulled either way. It's only getting pulled down because these cables are stabilizing it. So my resulting magnitude here is 0, okay? So my horizontals should be 0 and my verticals should equal 1,200 when I add them up. Okay, this picture I wouldn't draw all the time, just this one time so you can see why this is true. And then now I'm going to redraw this, and it should look really like this. So I'll try to block this out so you can see why, okay? So really, here's our ceiling. I know this is 45 degrees and this is 30 degrees, but I don't need that. Again, I want the angle from the positive x-axis. I want to know this angle and this angle. How would you get this angle and this angle? Well, these two lines are parallel. So these are alternate interior angles, and these are supplementary angles, right? So my theta 1 is going to be 150 degrees. It goes with cable 1. So my theta sub 1 is 150. My second cable is 45 degrees. Okay? So I know I need those. Those are really important. I need this fact, and I need those. Okay? Okay, so we're going to set up our vectors. So cable 1 is a vector. Let's go like this. Cable 1 is a vector. It has a magnitude, and then it has a direction. So we already know the direction is 150 degrees. So here's cable 1, right? It goes all the way to 150 degrees. So I just write it as a vector. Cable 2 is, oh, I multiplied it in, right? So M, I put here. M, I put here. So I just multiplied the M in. Cable 2, right here, is 45 degrees. So I multiplied my W out. That's a different magnitude. So here I put M. If you want to put like another letter, I don't care, but I put W because it's different, okay? So you multiply in the W. What we're really solving for this problem is what is M, what is W? That's what we're really solving for, okay? So notice right now we have we almost have two equations and two variables, okay? So we have an M, we have a W, and then what we're going to do is we're going to use this, and we're going to break this up a little bit because the horizontal should equal 0 and the vertical should be 1200. So I'm going to rewrite this using my horizontal component, which equals 0, and my vertical component, which equals 120. So notice what I did. I took my cosine 150m. So I don't need the I anymore because these are both I's. These are both horizontals. And then my, where's the other I? Right here. Cosine of 45W, right? Cosine of 45W. I don't need the I. If I add those, I should get a 0 because those come from here, right? So if I add those, I get a 0. And then I do the same thing with my sine values. My sine values are my vertical components. So sine 150m plus sine 45w should give me 1200. Now we really have two equations with two unknowns. That's what we have now. How do we work with that? The rest is on a calculator. Are you ready? So I'm going to do the rest on the calculator. I'm going to write it, but basically we have to solve for one, plug it into the other, and solve for the other. Okay? So you can use either one. I decided to use the second equation. And then if I use the second equation well, actually, I used the first equation. Just kidding. So I used the first equation, and then, because that says equals 0. And I said, okay, I'm going to solve for one of these. It doesn't matter which one. I solved for m. So when you solve for m, this gets subtracted to the other side, and then you would divide by cosine of 150, right? So this gets subtracted. I get my negative cosine 45, and then I would divide by the cosine of 150. So I would divide by that. Okay, so I left my W out here to make life easier for me. You'll see why in a second. But basically, you can see where this came from, right? From that first equation. Okay, you want this. This is important. Because a lot of this we're going to do in the calculator after this. But I'm going to write it out first. All right, I rewrite this second equation. Everything's the same here. Instead of m, I plug in this one. See how this has a W? Ooh, and then here's my sine of 45W, and that equals 1200. Okay, the rest is on my calculator. I'm going to show you the answers, but then I'm going to do it using my calculator. I hope you can see it. Okay. Sorry, you got to wait for me. Second plus 712. All right. Okay, so let me see if we can see. Oh, we can almost see all of it. Just about. Okay, So what I'm going to do is I am going to go ahead and I want to solve for, I think I have to solve for W first, and then because that has that equation, so here's all my W's, and then plug the W back into here. Okay, so how would I do something like this? I can think about it kind of an easier way. Are you ready? So if we want to think about it an easier way, what would we do if we had like something W plus something W equals blah, 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 right? So I could, if I had an easier equation, I'm going to do an easier equation. I'm just going to make it up. 2W plus 3W equals, 1200. Okay? So how would I solve for W? Well, I would add these values and I would get 5W equals 1200, and then I would divide by 5. So W equals 1200 divided by 5. So I add these and then I would divide that by that number. It's the same concept. I add the sine of 150 times that and that. That would be like my 5. And then 120 or 1200, sorry, divided by whatever's in my calculator would give me my W. So I'm going to do it on my calculator so you can see it, okay? And you should really do it with me. You should do it with me and pause it, okay? So I'm going to start in here. A negative, not a minus, but a negative. Oh, this is 45 degrees. Be careful. So my mode is going to be degrees. There we go. Negative cosine of 45 divided by cosine of 150. And then that's this number. And then I'm going to multiply that with sine of 150. So times sine of 150. And then I'm going to add sine of 45. So plus sine of 45. And then I'm going to do 1200 divided by that number. I'm going to keep my fingers crossed. Divided by answer. So second. And then on the bottom. And then I'm going to press enter. Yes, I got it. Okay, so that's supposed to be this first answer for W. I solved for W. How do we get M? Well, it's W times this. Okay, so I just have to multiply by negative cosine. Oh, sorry, I did that wrong. By a negative cosine of 45. And then I'm going to press enter. And then divide by a cosine of 150. There we go. So there's a lot of work on the calculator, and you gotta like practice it, okay? So I hope you practice with me right here, and then you're gonna ask me questions, all right? Okay, I'll see you later.